All right, welcome. Today, we're going to talk about transforming a really complex technical blueprint into a virtual network that actually works and is reliable. I think a great way to think about it is this. We're not just clicking buttons in a piece of software. We are literally constructing an entire digital city. And the goal? Make sure it works perfectly from day one.
So let's dive right in. Picture this. You're the architect. You've been handed the plans, you have all the raw materials, the pressure is on you to build this complex, interconnected city, your network, and it absolutely has to be flawless. So where do you even begin? How do you make sure you don't end up with massive traffic jams and power outages on opening day? Well, let's start with the single most important concept. Honestly, this is the one that's at the root of nearly every network headache out there, the huge gap between what you think you built and what's actually happening on the ground. What's so interesting here is how this splits our world into two distinct parts. Over on the left, you've got the blueprint. That's your intent. It's everything you configure, every rule you write in the UI. It's the perfect city you've designed in your head. But on the right, you have reality. This is the actual path a packet, think of it as a single car full of data, takes as it drives through your city. This is what your applications actually feel. And guess what? Almost every single problem we run into happens in that gray area. That gap between those two worlds. And this quote just hits the nail on the head. It's a major pitfall for so many operators. Just because you clicked save on some new configuration, that doesn't mean the network is actually doing it. Your blueprint might say, hey, build a bridge right here, but if the foundation is cracked, that bridge is just a drawing on a piece of paper. Our entire job is to make sure our intent is always being realized.
So, how do we guarantee that? How do we make sure our blueprint becomes reality? Simple. We follow a proven structured process. I mean, you wouldn't put the roof on a building before the walls are up, right? The exact same logic applies here. We need what's called a safe build order.
And here it is. This is the 6-step sequence that stops those confusing, hard-to-diagnose partial failures before they even start. Think of it like this. First, you establish City Hall. That's your management and control plane. Then, you lay the power grid to get forwarding capacity online. After that's solid, you build the major highways and the local roads, your routing tiers. And only then do you start putting up the actual buildings and connecting your workloads. Finally, you add the zoning laws and security guards, and then you set up your city maintenance crews to monitor everything. Following this exact order, it is absolutely non-negotiable for a stable build.
Okay, so we've got the blueprint, we've got the build order. Let's get practical. How does our shiny new digital city actually connect to the rest of the world? It's got to have highways, on-ramps, and off-ramps, right?
And that is where the edge cluster comes in. This thing is the critical piece of infrastructure. It's the gateway to the physical world. Just think of it as this massive interchange that connects all your local city roads to the national highway system. Everything, and I mean everything, that goes in or out of your city flows right through here.
So following our build order, first you prepare the raw materials for your bridges. Those are your edge nodes. Then you actually form the cluster, making sure it's strong and healthy. Next, you build the main highway interchange. That's the Tier 0 gateway, handling all traffic in and out of your city. And finally, you connect your local business districts to that main highway using Tier 1 gateways, which manage all the traffic within different zones of your city.
Okay, now listen up, because this is maybe the most important rule of all. After every single one of those steps, you must stop and test. Did that part of the bridge get built correctly? Can a single car drive over it? This habit, this constant small-scale verification, it's what separates a smooth, easy deployment from a weekend of frantic, painful troubleshooting.
But let's be real. Inevitably, something is going to go wrong. Your verification test is going to fail. The key is not to panic, but to ask the right question. Is the problem with the physical road itself, the transport? Is it a mistake I made in the blueprint, the intent, or is it something to do with permits and identity, the trust?
So, that leads us right into the most common construction hazards. You can think of these as the predictable potholes and weak points that can bring your entire project grinding to a halt if you're not actively looking out for them. And the most dangerous hazards? Well, they're the ones you don't see coming. They are the silent killers of any deployment. They're those tiny little cracks in the foundation that you overlook at the very beginning, but cause the whole structure to fail spectacularly later on. These 4 prerequisites right here, they are absolutely non-negotiable. First is your city's address book, your DNS, working perfectly so traffic actually knows where to go. Second is everyone's clock synchronized with NTP so that all events happen in the right order. Third,
Are all the road clearances, the MTU, consistent everywhere, so no giant data trucks get stuck under a low bridge? And finally, can everyone even get to the roads to begin with?
These other common mistakes, they all really just stem from violating the principles we've already talked about. Building things out of order, confusing the purpose of your main highways, the Tier 0, with your local neighborhood roads, the Tier 1. Not thinking about how a new traffic light, a stateful service, is going to affect traffic flow. Or, and this is a big one, thinking that giving someone keys to a building is the same as giving them their own completely isolated property.
Okay, so let's put all this together. We've gone from high-level theory down to some really specific hazards. Now, how do you turn all this knowledge into a practical operator's toolkit that you can use every single day?
Well, you do it by constantly asking yourself these questions. Don't just follow the steps, be able to justify why they're in that order. When a problem pops up, can you immediately identify which part of the city, which object is involved? Do you know exactly what good is supposed to look like after each and every step? And can you pick the right tool to diagnose the problem, whether it's a citywide power outage or just a single broken traffic light?
So, if you remember nothing else, internalize this mental model. Make it your mantra. Prepare foundations, deploy capacity, create routing, add services, and then monitor health. That right there is the core philosophy for building a digital city that's actually built to last.
And that leaves us with one final thought. The construction is done, the ribbon has been cut, but the job is never truly over. The real work of an architect and a city planner is making sure that the city doesn't just exist, but that it actually thrives. So your city is built, but the real question is, and always will be, is it healthy?